Oh, sorry about this delayed video, Year 9. Here we go, though. Right, I'm going to talk you through this. This is kind of your best indication of what's coming up at the end of the exam. Pretty complete list, so make sure you're happy with everything that I'm about to do, I would say. Right, okay, let's get my red pen. Okay, check it works. We're good. Right, so multiplying decimals. Multiply the digits, 7 times 8, which is 56. And as you can see, there's one decimal place here, one number after the point here, and one number after the point here, giving me 2 in total. So I'd also need 2 in my answer. So I need to put the decimal point at the start there, right? If you compare that with something like 0.02 times 0.3, I don't know, right? Then I'm doing 2 times 3, which is 6, but there's 2 numbers after the point there, and 1 after the point there, so that's 3 in total. Well, 6 is only 1 digit, so all I'd have to do is jump back 1 place, and another place, and a third place before I put my decimal point. So then I've got 3 in the answer. Now, not strictly true, what we're calling that, right? Because we're not dividing by a decimal, we're dividing a decimal by a whole number. And in that case, I would suggest that doing a bus stop is absolutely fine. 12 doesn't go into 3, put the point there. Carry the 3 to make it 39 now, and let's look at 39. 12 goes into 39 3 times, remainder 3, and 12 goes into 36 3 times with no remainder. So your dividing decimals is your bus stop. I'm missing an S, and I have bus stop, right? Rounded to significant figures. So the second significant figure, chaps, is the second digit. In this case, the second digit is in the hundreds column. So I'm rounding to the nearest 100. So we've got the number 4,837, or to the nearest 100, 4,800. I think we need to be careful with significant figures of small numbers, like 0.04917. Here, the second significant figure is the 9, because it's the second non-zero digit, right? We wouldn't change the naught, or this naught, or this naught, or the 4, and then we'd look at the 9 and go, right, well, this is where we're chopping this after the second significant figure. But because it's followed by a 1, it will round down or stay as a 9. If that was 5 or more after it, obviously that would round up, okay? Whereas 2 decimal places is an actual specific point in the number. It's the second decimal place, the second number after the point that we're chopping off. So in this case, it would be 6.78. Or if I was something like 4.2391 and we were rounding to the second decimal place, this would be 4.24 because it's followed by a 9. So just a bit of rounding for you there. Estimate. Make sure you do estimate and don't try and work this out actually, right? So there's not a lot of room on here. I wish I'd left a little bit more room, but I'll just keep working down the side, okay? So for estimate, we're rounding to the nearest 10, or the nearest 1, or the nearest 100, depending on the size of the number. So any number like this, which is less than 10, I'm going to round to the nearest whole number. But any number bigger than 10, I'm going to round to the nearest 10. So we get 20 times 6 in brackets. So we're going to do that first, divided by 2. Well, 20 times 6 is 120, and then if I half it, divide it by 2, I get 60. Okay. Remember, this is more likely to be written like this, with a dot and a dot, to show that the 2 and the 3 are recurring. Okay, so we write the 2 digits that are after the 0, after the decimal point. And in this case, both numbers are recurring. I always tell you to take away from that any digit that's not recurring, but because both are recurring, we're not taking anything away. So actually, I don't even know if there's any point in that. And then I say, right, on the bottom, for every recurring digit, for every dotted number, put a 9. In this case, they're both dotted, right? So let's do one that's a little bit harder. Let's go for 0.123, but only make the 2 and the 3, right? Well, this time I would write 123, but I would take away this non-recurring digit to get 122. And on the bottom, instead of 99, I would have 99, and I would put a 0 for this non-recurring one there. So that would be 122 over 990. back here to standard form. Let's start with writing in standard form. The decimal point, you always put one number before the decimal point. So this wouldn't be 0.56 or 56. It has to be 5.6. Right? Times 10, and we count the jumps. 1, 2, 3, or to get that decimal point there after the 5, I have to move it 4 places down the number. All right? Okay, calculations in standard form. Look, there are a couple of ways to do this, right? There are a couple of ways to do this. And if this is not the method you use, that's fine. There is probably only one way to do this. If you're adding two bits of standard form, the best way is to take them out of standard form as numbers. So do 2 times 10 times 10 times 10, or 2 times 10 to the power 3. 2 times 10 3 times, plus 4.29 times 10 is 42.9, times 10 again is 429, right? And then times 10 a third time, a fourth time, and a fifth time. So that ends up having 3 zeros at the end as well. Now, for adding these, if I was lining them, I tend to, you don't have to, put the bigger one on top and the smaller one underneath, and I'm adding in this case. 11, so it's 1 carry 1, 3, and 4. I'm back into standard form with your answer. So 4.31 times 10. And this time, to get the decimal point after the 4, I'm going to jump up the number 1, 2, 3, 4, 5 jumps. Okay. And the other standard formula I've done is a multiplying. Look, you can do it the way I just added. You can change them into big numbers and then multiply them if you prefer that. But with multiplying, you can go direct. You can go 3 times 4 is 12 times 10 and add the little numbers. Because when you multiply two things that are the same, so you can do it that way. However, you may notice that's not in standard form because that number is too big. That number is above 10. To be in standard form, that would need to be 1.2. So because we have to make the 12 a little bit, a place value smaller, to counteract it, we'd need to add one on there. As I said, the other way is to write those as numbers. 3 with 3 zeros times 4 with 1, 2, 3, 4, 5 zeros, and do the multiplication. 3 times 4 is 12, and then add your zeros. 1, 2, 3, 1, 2, 3, 4, 5, and put it into standard form. 1.2 times 10, whichever you prefer. Okay? So either of those calculations can be done as numbers. We keep going. Nth term. Every so often you'll notice in this video there's little breaks because I can't record them as full videos, unfortunately. They do them into a 10-15 minute slot. So if it looks like the volume has jumped, it's not. I've just had to take a break, but I am going to keep going until I get to a break. The computer will tell me that. Okay, so let's start with this one. A linear one that's going up in 3s. So it'll be 3n plus 2, because if we came back 3, we would go back to plus 2 from there. Whereas this one, I'm actually going to write in full 5, 8, 13, and 20. We mentioned in class the other day, this one goes up 3, then goes up 5, then goes up 7. So we're going to have to bring in the second difference. And the second difference is the difference in the differences, which is 2. Now, this is tough, right? But we half the second difference. Half of 2 is 1. And then write that. So this would be 1n squared, but I don't need to write the 1 there. It's not really doing anything. Okay, so n squared, right. However, it's not n squared because the n squared sequence would be 1 squared, 2 squared, 3 squared, and 4 squared. But my numbers aren't 1, 4, 9, and 16. They're 5, 8, 13, and 20, if you look at my sequence up here. So my numbers are all 4 more than this. So my sequence is n squared plus 4. That is my answer. Okay, that's tricky. That's the first real A-starry topic we've got in there. Okay, we're going to keep working down the page. Right, the first 4 terms of 2m plus 1. Well, the first, basically, work it out when n equals 1 to get the first term, then when n equals 2, then when n equals 3, and then when n equals 4. So when n equals 1, 2 times 1 is 2, plus another 1 is 3. When n is 2, 2 times 2 is 4, add another 1 is 5. 2 times 3, add 1 is 7. And 2 times 4, add 1 is 9. So the first 4 terms of this would be 3, 5, 7, 9. Okay, collecting like terms. Yay, nice and easy. Start with the x's. 3x, add 2x. I'm going to write this answer here, 5x. And then what are we left with? Plus 5y minus 8y. Oh, we're taking away more y's than we've got. So this is going to go down into the minus y's. 5y take away 8. 5 take away 8 is minus 3y. Right. Factorizing into a single bracket. Okay. Two terms. What are the common factors? Well, I can see that 6 goes into both these numbers, 12 and 18. But also there's an x in both. 6 times what makes 12? 2. Don't need to put an x by the 2 because I've taken the x outside the bracket. Then 6 times what makes 18? 3. But I do need an x here because it's x squared and I've only taken one of those outside the bracket. So that's factorizing into a single bracket. Whereas expanding a single bracket, the opposite, involves doing the opposite. Instead of dividing and working out what you need, is times in. So 4x times x is 4x squared, and 4 times 3 is 12 with the x there. Double bracket. We talked about different ways to do this. I'm going to use like what I call smiley face. So we're going to start with left eyebrow, x times x, all these times sums. X times x is x squared. Then we'll do the nose, plus 2 times x, which is plus 2x. Then we'll do the mouth, minus 5 times x, which is minus 5x. And then we'll do the right eyebrow, which is plus 2, and it's not 2 take away 5, it's plus 2 times. Remember, all these are times sums. It's 2 times 5, which would be minus 10. Okay, then the simplifying bit, well, there's nothing I can do with the x squared animal, but then I've got 2 of these animals, take away 5 of these animals, which gives me minus 3x, or minus 3 of that animal. And then we've got a number animal on the end. That seems like a good place to take a break in this video and come back to you. Sorry about the little jump there. We've actually got a couple of minutes left on this part of the recording. Like I said, this is not professional. You're going to see lots of jumps. So we're back to factorizing, putting in brackets. But this time, what we call a quadratic. X squared, x's, and a number. This will require a double bracket with an x and an x. Now, we are looking for 2 numbers. And those numbers need to team. They need to times to make the number on the end, which is 12. They need to add or take away to make the number in the middle, which really importantly, you don't include the x, just what's attached to the x, is plus 7. And super important that it's plus 7. So 12, I'm thinking 1 times 12. I'm thinking 3 times 4. I'm thinking 2 times 6. Now, I'm not making 7 with a 1 and a 12 or a 2 and a 6, but I can with those with a 3 and a 4 not by taking them away. And usually this is an add one. I do prefer to take away ones, but okay. So my 2 answers here are 3 and 4. 3 and 4 will times to make 12 and will add to make 7. They will team, times to make the end, add to make the middle, and they go in there. Positive 3 and positive 4. There. Sorry if there was. I need space for this. I do need space for this. Let's start bringing these down here, okay? Right, this is horrendous. 2 of our hardest questions so far have been what's linked to quadratics. Quadratic nth term, which we did a couple of minutes ago, and then factorizing a quadratic, the one we just did, but this one in particular. This one, a nightmare, because it's got a 3. It's got a number before the x squared. So here there are 3 subtle differences to the technique. Subtle difference number 1. We put 3x in both the brackets, which is already a problem because 3x times 3x is 9x squared, and that isn't 9x squared, but this sort of sorts itself out at the end, okay? Difference number 2. When we team, we times to make the end, we add or take away to make the middle. Here, my middle number is positive 2. Yeah, really important that it's positive, like I said, right? But that end number, which is minus 5, if there is a number at the start, you have to do start times end in this one. So it's 3 times minus 5. So actually, my new end number, the end number I'm going to use here is minus 15, right? Again, I'm not that worried that it's minus 15. We'll sort that, right? But I'm thinking 3 times 5. And to get plus 2, I'm thinking 5 take away 3. In other words, the 5 is positive and the 3 is negative, which kind of works over here. Because if the 5 is positive and the 3 is negative, well, minus 3 times 5 would give me minus 15. So if we make this one work, that one just will work, right? So my two numbers are minus 3 and plus 5. Right? Now, what you will find is at one or both of these brackets, in which is this case 1, you can divide something out of it. It can be simple. It's almost like the bracket can be simplified, right? Not a 3 and a 5, but a 3 and a 3. We can divide those both by 3. We can simplify that bracket down to divide them both by 3. You get x minus 1. We decided not to do anything with the other bracket, and that would be the answer to that. Then we come back to something that's not so mental, okay? Basically, work that out, but put in there the number 4 instead of a. But it's not 34, it's 3a. 3a means 3 times a. So 3 times 4 is 12. Take away 2 would give you an answer. Y equals 10, right? Okay, solving equations. Let's start with an easy one. 5x minus 7, bit of magic bridge for you, okay? So here, leave my x's on the left, we always said, but any loose numbers, they can go over with on my number side of the bridge. However, it's a magic bridge, so they're not minus 7 anymore, they're plus 7. So my new answer over here, I've now got 18 over here anymore, I've now got 25. And this is where you try and work at the value of one of my x's, right? Because we're talking about 5 of them here, but we don't want to know what 5 is worth, we want to know what 1 is worth. So we need to divide that answer by 5, and 25 divided by 5 is 5. And have I got space to do that last one here? Probably not. Oh, it's going to be tight. Look, we'll quickly start it on this page and move on if we need to. So we've got 5x minus 14. Okay, similar sort of thing, but this time you need to go over, you don't belong on my x's side. However, there's 3 of you, 3 of my x's, hang on, you do need to come over on the side. You kind of like swap positions, guys. The numbers should be on the right, the x's should be on the left. So let's have a look what's moving, what's not. The 5x isn't moving, but coming over to join the 5x is 3x, but no longer positive, now negative. The 18 over here is moving, but coming over to join them was negative 14, is now positive 14. So I had 5, I'm eliminating 3, so I'm going down to 2 on the side. I had 18, I'm adding 14 on, so I've got 32. But like we said above, I don't want to know what 2 is worth, I want to know what 1 is worth. So I need to divide my final answer by 2. So each x is worth 16. Into the next section. We've done a fair bit of this, so I am flying through this, right? First of all, badly written or what, right? Half, 3/4, 2/3. We need the bottom numbers to be the same. They all go to 12, right? Times by 6, times by 6, times by 3, times by 3, times by 4, times by 4. Smallest, half, which was 6 out of 12. Next smallest, 2. 2/3, which has become 8 over 12. And then the biggest, 3/4, which has become 9 over 12. So I've put them in ascending order, right? Smallest to biggest. Adding fractions, again, we've got to make these the same, right? Bottom number is the same. Don't want 5. Let's double it to 10, so it's the same as this, but we also need to double the top. So we end up with 4 over 10 plus 3 over 10, which equals 7 over 10. Finding fractions of an amount, take the amount that you're finding the fraction of, split it into the bottom number of pieces. So in this case, split it into 8 pieces. So each part is with 8, but we actually want 3 parts. So 8 times 3, which is 24. Or what we would say, divide by the bottom times by the top. Simplify a fraction. We are Russian, I know. Look, some might spot that 6 goes into these, but I quite like that. Let's half them while we can. pardon me, to 9 over 12, and then go, well, they're both in the 3 times table. Let's divide these by 3. 3 goes into 9 3 times, 3 goes into 12 4 times, and now there's nothing more I can do. I can't divide 3 and 4 by 2, for example, or 3 or anything else. Okay, we haven't got a calculator, so we're going to go down the route of 10% and 5%. 10% of 240 is 240 divided by 10, which is 24, whereas 5% would only be half that amount. So 15% is 10% add 5%, so 36. Now a little bit of AA star questions in here. Nice, we've come across that. Okay, a £72 after a 20% discount. Find the original price. Okay, the 20% has already been taken off the amount. What I am looking at, therefore, that £72 represents 80% of the original value. Okay, because 20% has already come off to make it 80%. We want to get back to the original. We want to know what it originally was, what 100% was. So we're going to go via 10%. How many 10s go into 80? Oh, that's 8. So I need to divide this by 8 and also divide this side by 8. So I go down to £9. And then to get up from 10% to 100, I'd need 10 of them. So let's times that by 10 and times that by 10. Hopefully you can write these out a bit neater than me with some £90. Okay. Percentage multipliers. Now we haven't got a calculator, so we're going to just write what the sum would be rather than actually do it. Okay. Sorry, stop for a drink. Write the multiplier for a 6% increase. Okay. We're going to add 6% on to the original, add 6% onto the 100. So we're looking for 106% of the number. As a decimal, that would be times in by 1.06. And if we want to do that 3 times, we put a little 3 there. Okay. And that's it. That is the multiplier. That is how you would increase something by 6% 3 times, as opposed to this is how you would increase something by 3% 6 times. So that hopefully kind of shows you what's going on there, right? 180 is a product of prime factors. I'm going to go for 2 times 90. I'm going to go for 3 times 30. I'm going to go for 3 times 10. And I'm going to go for 2 times 5. So my prime numbers are 2, 3, 3, 2, and 5. Or in index form, the number 2 in my answer appears twice, times the number 3 appears twice, times the number 5, which only appears once. So that is my final answer. Okay. HCF. Right. Oh, it's going to take a while, this. Okay. The biggest number that goes into both. What you can do, right, is do both these as product of primes. So this one, oh, have I got enough room? Would be 2 times 30, which would be 2 times 15, which would be 3 times 5. So my answers are, oh my gosh, you can't see that. 2, 2, 3, and 5. Whereas this one, 84 would be 2 times 42. This would be 2 times 21, and this would be 3 times 7. What you have to then do, okay, sorry, I should have shown the trees, but I am just rushing this, right, is pull out common factors. So there is a 2 in both the trees. There is another 2 in both the trees. Boom, 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 boom. There is also a 3 in both the trees. What I'm left with is a 5 in this tree and a 7 in this tree. So they are not common. They can't be pulled out. If you times those, you get 12. That is the highest common factor. That is the highest common factor. Okay. And then a little bit more, right? The easiest rule is if you times 2 things, you add the indices, right? That's the easy rule. If you're dividing, you take away the indices. But then you've got these nasty ones that we did. And what we said is we're going to ignore negatives. Negatives mean flip, or reciprocal is a better word. So 4 squared is 16, but I don't know if you can see it even on there, but that's a minus there. So actually it's the flip of 16, so it's 1 over 16. We also talked about a flower and a root, right? Or a power and a root. So in this case, the bottom number, the root is 3. So I want the cubed root of 27, which is 3. There's another rule that says anything to the power 0 is 1, right? And then we've got the lot. We've got a square root, a 2 on the bottom, which is 2. But we've also got a 3 on the top. So I need to take my answer and cube it with the power 3 to make 8. And we've got a minus. So we've got to flip our answer so that it's not 8. It's 1 over 8. Quick check on time. We're okay. Let's power through. 3 probability questions, okay? Where am I actually going to do these? I tell you what, I'm going to take a little break again because I'm going to come back and leave myself space to do these questions on the page for We're just doing this third little part of this video, but I will obviously merge these together to make one longer video for you. So the 3 probability questions are the 3 things we've been working on. Start with the Venn diagram. The circles will be there for you, okay? So, all right, it's even harder than I'm making you draw these, but that's okay. A class of 30 pupils. I need to make sure that my numbers add up to 30, okay? We're asked if they play rugby or football. 12 play neither. They don't belong. So if they were asked rugby or football, I guess one of the circles represents rugby and one football. But 12 play neither, so they don't belong inside. So there's the first 12 pupils taken care of. 3 play both. So they sit in the middle because they belong in the rugby circle and in the football circle. 7 play football. Here's the big mistake. A lot of people are going to put that 7 bang in there. But if I put a 7 in there, I now have 10 people playing football. Right? If that had said, though, 7 only play football, as in they play football but they don't play rugby, yes, that 7 could go in there. But this is not what this says. This says altogether, in total, 7 play football. So I need to take the 3 that play both away from that 7. Now I have 7 playing football, okay? And it says complete the Venn diagram, and you must be thinking, yeah, but there's a missing number. That's where that comes in. We have 30 people together. So far, I have only put 12, 13, 14, 15, 16, 17, 18, 19 people in there. So we must have another 11. Now I have 30, okay? You probably will get a part B, right? So this bit here is like a part B rather than, once you've done this, I don't know why that just moved, part B, calculate the probability. Why does it keep moving up there? I don't know. Calculate the probability that a pupil selected at random plays rugby. Answer me this, how many play rugby? I hope you wouldn't put 11. There's 14 rugby players I can see within the rugby circle. 14 out of 30 in total. So 14 out of 30 play rugby. Therefore, the probability of picking someone who plays rugby is 14 out of 30. Our next probability question is to model the probability with a tree diagram, which looks like this. And then we rebranch from here. And we rebranch from here. John has breakfast is the first event. JB, John breakfast. Now, there are 2 things that can happen here. Yes, he will. Oh, no, he won't. And we're told that the probability of yes, he will is 0.4. Okay? Therefore, 40%. Therefore, the probability that he will not have breakfast is 0.6. So that's event 1 taken care of. We're now on to event 2, which is, will Kieran have breakfast? Again, the 2 options are yes or no, but this time I write them twice. Okay? The chance of him having breakfast is 0.7. Therefore, there is a 30% chance he doesn't, but those numbers need to be copied down onto these branches. What these tree diagram shows us is the 4 things that can happen. Either John and Kieran will both have breakfast. Yes, yes. Think of a little man who's gone for a walk up the branches. Yes, yes. Or the little man could walk the yes-no branch where John does, but Kieran does not. Or the no-yes branch where John does not, but Kieran does. Or the no-no branch where neither of them do. Okay? And then the part B here is, okay, now use the tree diagram to calculate the probability neither of them have breakfast. That is the option I am looking for. Neither of them have breakfast. Imagine, please, an imaginary times line here. Whenever we're doing probabilities, a combination of probabilities would need to be times together. So 0.6 times 0.3 is 0.18. Okay. What's the most awkward one here? They're all quite nice, these numbers. Again, I'd just be careful. We talked about multiplying decimals. It was the very first question. But just in case you get something like 0.2 times 0.1 or something like that, that you don't put, it's 0.2, right? It's 0.02 because you'd need 2 decimal places. Look back at question 1, go back to the start of this video, and because multiplying decimals is so important to tree diagrams. Okay, but that's how we complete them now. Right, and then the A* one here, massive A*, probably the hardest question we get. One of the hardest in maths, I would say. Okay, so conditional. In other words, we're taking 2 balls in this case. Could be three, right? And we're not putting the ball back that we take. So we're going to start with 2 yellows, 3 blues, and 1 green. So A. Calculate the probability I choose a yellow followed by a blue. So yellow is 2 out of 6, followed by, a little bit like our tree diagram, followed by then times a green, but a blue, sorry. But there are 3 blues. However, because we've already taken a yellow and not replaced it, there are now only 5 balls left. 2 times 3 is 6. 6 times 5 is 30. Okay? Right. Calculate the probability I take 2 balls the same color. Right, now there's 2 probabilities here. I could get a yellow with a yellow, or I could get a blue followed by a blue. Could I get a green followed by a green? No, because there's only 1 green, and if I take that, there wouldn't be a second to take out, so that's not even an option. So let's start with the yellow-yellow combination. There are 2 yellows out of 6, but if I take a yellow, there would then only be 1 left, and there would only be 5 balls left. That's 2 out of 30. There are 3 blues out of 6, but if I take a blue, there will only be 2 left, and there'll only be 5 left, so that's 6 out of 30. We then need to add these together, right? Add that. It's not the best written out. I just ran out of room. Add your answers, which is 8 out of 30. I'm going to add a part C. Just in case. 8 out of 30 is the probability of pulling 2 the same. If I added a part C, which said, what is the probability of 2 different? To save you working out all the combinations like yellow, blue, green, yellow, I don't know, there's loads of them. If 8 out of 30 combinations involve being the same, then the other 22 combinations involve being different. So all I've done is 30 take away that 8 to get the 22 other combinations which involve different colors. Voila! End of revision. Good luck for tomorrow. Go and smash it.